Bismillahirrahmanirrahim. Today our discussion topic is potentiometry. What is potentiometry? It is defined as branch of electrochemistry which deals with the study and measurement of electrode potential. So what is electrochemistry? Electrochemistry, chemical activity of analyte on the basis of electricity is measured is called electrochemistry. When activity is in the form of voltage, then it is called potentiometry. When activity is in the form of current, then it is called polarography. What do you mean about current? Current is produced due to oxidation reduction study. Maximum current means complete oxidation reduction. Current is studied by varying the voltage. At a certain potential at which maximum current is observed, we have to find that potential. So next definition, what is electrode? It is defined as one of the two terminals of an electrically conducting system or cell. There are two types of electrodes. Cathode and anode. What is chemical cell? It is defined as a system in which chemical energy is transformed into electrical energy. The chemical energy is transformed into electrical energy by an oxidation reduction reaction. What is oxidation? Oxidation always occurs at cathode. Removal of electron is called oxidation, as M is oxidized by removal of one electron. You can see the equation, M is oxidized by removal one electron. What is reduction? Reduction always occurs at cathode. Accepting or addition of electron is called reduction. Accepting or addition of electron is called reduction, as M+ ion is reduced by accepting of one electron. You can see the equation here, M+ ion is reduced by accepting one electron, and it will be converted into the form of metal. What is electrode potential? Let us consider metal M, which is dipped into a solution of its ion M+ as shown in the figure. Now some of the metal atoms ionize, that lose electron and go into solution. This is denoted by an arrow. Some of the ions M+ present in a solution accept electron and becomes metal atom and deposit on metal surface. This is denoted by dotted arrow. According to Nernst theory of solution pressure, an equation is set up between these two tendencies of metal M and metal ions M+. In normal cases, these two tendencies are unequal and the metal and solution will have different potential. This difference of potential between a metal M and solution of its salt is known as electrode potential. So electrode potential depends on nature of electrode, and second one is concentration of solution at given temperature. What is standard electrode potential? Standard electrode potential is denoted by E naught. When the concentration of the solution is 1 molar and the temperature is specified to be 25 degrees centigrade, the electrode potential is called standard electrode potential. So next topic, that is what is potentiometric titration. Potentiometric titration is a very important tool for determining the concentration of unknown solution or sample. In the potentiometric titration, the concentration of the unknown solution or sample is determined by a change in the potential of the indicator electrode. Here, the potential of the indicator electrode is directly dependent on the concentration of the unknown solution in which the indicator electrode is dipped. So the potential of the indicator electrode linearly rises with the concentration of the unknown solution. At the end point, when the concentration of the solution changes, there is a sharp change in the pH. There is a sharp change in the pH or potential of the indicator electrode, so the endpoint can be easily detected. So next, what is the basic principle of potentiometric titration? Basic principle of potentiometric titration, or you can see instrumentation. In the potentiometric titration, if we see the instrumentation, there are two electrodes. You can see the diagram. There are two electrodes. One is the reference electrode and the other one is the indicator electrode. And the reference electrode, it may be a standard caliber electrode or it may be a silver chloride electrode. So we understand about the reference electrode. Reference electrode potential remains constant in all over the reaction and is independent of concentration of analyzed solution. You can see in the diagram, this is a beaker in which the analyzed solution whose concentration we have to determine. And there are two electrodes. One is the reference electrode and the other one is the indicator electrode. The potential of this reference electrode remains constant and is independent of the concentration of analyzed solution. The second electrode, this is indicator electrode. You can see this is glass electrode. This is indicator electrode. This is the indicator electrode and its potential arises with the concentration of analyzed solution in which it is dipped. So its potential is linearly dependent on the concentration of analyzed solution. Now these electrodes are linked with potentiometer. You can see in the diagram, these electrodes are linked with a potentiometer. And in the acid-base titration, it will attach to a pH meter. So in this way, we can determine the pH of this solution. Now in the burette, here is another solution. You can see this is the burette, and here is another solution. If we carry out an acid-base titration, then it will be a base. And if we carry out redox reaction, it will be a reducing agent in the burette and oxidizing agent in the beaker. So in this beaker is present of unknown concentration, which is put drop by drop in this solution. In the first half of the reaction, when in the starting we insert the solution in a larger portions or larger amounts, and we calculate the potential of the electrode by this potentiometer. And afterwards, when the reaction is to be completion, then we add the solution drop by drop so that we approaches the end point. When the end point comes, we see at the potentiometer there is a large change in the potential, so we can determine the concentration of the solution by plotting a graph. By plotting a graph, we can determine the end point. Next point, so the other point, that is end point detection or equivalence point detection. There are two different methods by which we can determine the end point of the titration. The first method is that we know that we are adding the volume of the titrant from the burette at the regular intervals, and then by adding the volume of the titrant, we are observing the EMF or pH of the solution. So we will plot a graph between the volume of the titrant. So we will plot a graph between the volume of the titrant added and the change in the EMF or the pH. When we plot the graph, we get a sigmoidal curve. Such type of curve is called sigmoidal curve. Such type of curve is called sigmoidal curve. In this type of curve, there is a sudden change. There is a sudden increase in the EMF, and we get a steep slope like this. So the end point will be exactly the half of this steep slope. This will be the end point of this reaction. So this will be the endpoint of this reaction. The next graph you can see on the x-axis here volume of titrant added, and on y-axis delta E divided by delta V. Delta E means change in the EMF with the change in the volume of the titrant. We will get maxima. So this maxima indicates the endpoint. So this is the equivalence point or endpoint detection. Next, what are the advantages of potentiometric titration? Potentiometric titration can be used to titrate colored solution where visual indicators cannot work. Furthermore, in the visual titration of very dilute solutions, the color change of an indicator cannot be located, but by using potentiometric technique, the equivalence point of the titration can be accurately determined. So these are the advantages of potentiometric titration. The next topic that I am going to discuss is different types of reference electrodes and indicator electrodes that are used in potentiometer. So first we will discuss the different types of reference electrodes. There are three different types of reference electrodes that are used in the potentiometer. First one is the standard hydrogen electrode. Second type is the saturated calomel electrode, and third type is the silver chloride electrode. So now coming to the first one, which is standard hydrogen electrode. If we see the general view of this standard hydrogen electrode, in this electrode there will be a platinum wire that is dipped in a solution on one end in 1 molar H+ solution, means it will be in 1 molar HCl solution. We will bubble the H2 and H2 gas, hydrogen gas at 1 atmospheric pressure under the standard condition when the temperature is 25 degrees centigrade at the 1 atmospheric pressure. And this will be the standard hydrogen electrode. And the EMF of this is taken as 0 volt. You can see E naught is equal to 0.00 volt. And the reaction that takes place in this electrode is H2 will be converted into 2H+ by removing 2 electrons. The second type of the reference electrode, that is saturated calomel electrode, which is also known as standard calomel electrode. This saturated calomel electrode is very widely used electrode as the reference electrode, and this type of electrode, there is a narrow tube, and here the slurry of mercury and mercurous chloride in the saturated KCl solution, and in this there is platinum electrode. And at this standard condition, its electrode potential is E naught is equal to plus 0.2422 volt. The third type of reference electrode is the silver chloride electrode. Silver chloride electrode, and it is also very widely used electrode. In this type of electrode, there is a silver wire, and it is coated with AgCl paste. And in this paste, and in this wire is in contact with the 1 molar solution of the AgCl, and the reaction takes place is a silver ion plus chloride ion will give us silver chloride AgCl by removing 1 electron. So E is equal to, E naught is equal to 0.199 volt. So these are the three different types of reference electrodes. Now coming towards the different types of indicator electrodes. There are three different types of indicator electrodes which are used in potentiometric titration. First one is metal indicator electrode. The second type is the inert electrode, and the third type is the glass membrane electrode. So coming to the first one, what is metal indicator electrode? In this type of electrode, the potential is generated due to redox reaction on the metal surface. These type of indicator electrodes are generally of two types. First one is first order indicator electrode, and second type is the second order indicator electrode. In the first order indicator electrode, you can see silver ion, zinc, and zinc oil hidden into Zn plus. The metal is direct in contact of its ions, so the reaction takes place is that the silver metal is converted into silver ion by removing one electron. The standard EMF of the cell is that E naught is equal to 0.800 volt. Second type is the second order indicator electrode. The metal is in contact of its ions that can form the precipitations. For example, a silver wire is dipped in the solution of chloride ions. Then we get the second type of indicator electrode. Silver plus chloride ion Cl negative will give us AgCl by removing one electron. Second type of indicator electrode, that is inert electrode. In the inert electrode, we use platinum wire, carbon wire, or gold wire that is dipped in the analyzed solution whose concentration we have to find out. Third type is the glass membrane electrode. The potential generates at each side of the glass. The glass membrane is made up of sodium oxide Na2O, aluminum oxide Al2O3, and silicon oxide SiO2. Inside the glass bulb, solution of HCl and KCl is filled, and this type of electrode, silver acetate coated with AgCl. So these are the three different types of indicator electrodes which are used in the potentiometric titration. Next, I am going to discuss different types of potentiometric titration. What are the various types of potentiometric titration? There are four types of potentiometric titration. You can see first one is the space titration, second one is the redox titration, third one is the precipitation titration, and fourth one is the complexometric titration. So coming to the first one, which is acid-base titration. In acid-base titration, as from the name it is clear, in this type of titration, neutralization reaction takes place in the solution. If we consider there is a beaker and there is an acid solution of the unknown concentration, and from the burette we add the base solution, so that neutralization reaction takes place in the analyzed solution, and at the end point there will be a certain change in the pH of the solution. So in this case, the end point is determined in the term of pH of the solution. So here we will use the term pH. So here the reference electrode generally used is the saturated calamine electrode, and indicator electrode is the glass membrane electrode. So the potential of the cell is given by the E indicator minus E of the reference. You can see E cell is equal to E indicator minus E reference. Electrode potential of indicator is given by E naught of the indicator minus 0.0591 log concentration of hydrogen ion minus E reference. It means the standard electrode potential of the reference. If it is the calamine electrode, then its value will be 0.2422. So we can put it and we can get out the value of E cell. So this is the equation of E cell. Second type of potentiometric titration is the redox titration. In this type of titration, the oxidation reduction reaction occurs in the solution. So what happens if in this solution there are ferrous ions, Fe plus 2 ions present, and we add oxidizing agent such as the cerium Ce plus 4 ions from the burette. The solution containing the Ce plus 4 ions that acts as oxidizing agent. So what happens? It will oxidize the Fe plus 2 ions into Fe plus 3 ions. It will convert ferrous ions into ferric ions. So the redox reaction takes place, and at the end point, all the ferrous ions Fe plus 2 ions will be converted into ferric ions Fe plus 3 ions. So there will be a sudden change in the potential of the cell, and here the reference electrode potential that is, and here the reference electrode that is used generally is the saturated silver electrode or silver chloride electrode. And here the indicator electrode we use platinum wire that is dipped in the analyzed solution. Here the EMF of the cell is given by the standard electrode potential of the indicator electrode plus 0.0591 divided by N into log concentration of the oxidizing species divided by reducing species minus the standard EMF of the reference electrode. So this is the equation of the E cell. The third type of the potentiometric titration is the precipitation titration. Precipitation titration, when the addition of the reagent from the burette leads to the formation of precipitates, and then this formation of precipitates can be used as an indicator for the endpoint detection. For example, if there is NaCl solution in the beaker, we add from the burette the silver nitrate solution, and thus it will lead to the formation of silver chloride, and it gives a white precipitate. So this can be used as an indicator. It will cause a change in the EMF of the cell. So we can detect the endpoint for the reaction. NaCl plus AgNO3 will give us AgCl plus NaNO3. The EMF of the cell here will be given by E cell will be equal to E naught of the indicator. E naught of the indicator means standard electrode potential of the indicator plus 0.0591 divided by N into log concentration of the M into N plus ions minus standard electrode potential of the reference. Here the reference electrode used that are generally saturated calcium electrode or silver chloride electrode, and the indicator electrode we generally used the silver wire that is dipped in the analyzed solution. The last fourth type of the potentiometric titration is complexometric titration. As from the name, it is clear that in this type of titration, the addition of the reagent leads to the formation of complex. So we add generally from the burette activating agent such as EDTA. EDTA is the abbreviation of ethylene diamine tetraacetate. So it acts as complexing agent. It can form complex with the metal ion. So metal EDTA complex is formed, and this can be used for the detection of endpoint. So these are all about potentiometry. Next topic we will discuss polarography.